Hello everyone, I'm Roy. In this session, we're going to look at a real EWRB electrical service technician exam result. The candidate scored 89 marks, a strong pass. We'll break down the report and focus on the key areas where marks were lost so you can avoid the same mistakes. Here are the 8 errors from the knowledge deficiency statement, each linked to section 8 of the teaching guidelines. These errors often look basic, but the exam tests the finer details. In this review, we'll focus only on those specific points that cost marks, not the general knowledge you already know. Let's go through them one by one. Marks are lost when candidates mix up shock levels. 10 milliamps is the can't let go point, which is why 10 milliamps RCDs are used in high-risk areas. 30 milliamps can cause breathing failure, and 30 milliamps RCDs are set to trip before current rises further. Fibrillation risk starts around 50 milliamps, becomes likely at 100 milliamps. 100 milliamps is too high for shock protection. It may be used for fire risk, but not for people. And at 500 milliamps, burns and death are certain. The key is 30 milliamps RCDs don't mean fibrillation starts at 30 milliamps. They trip early to prevent it. Most marks are lost by mixing up RCD types. An SRCD is a socket outlet with RCD built in, not the same as a Type S time delay RCD. A PRCD must be manually reset, it will not restore power by itself. An RCBO combines RCD and MCB functions, and an RCCB is just another name for RCD. The key is knowing which device is which and how it works. The trap here is vague answers. A competent person is not just licensed, they must have the training, skills, knowledge, and qualifications to apply the safety regulations in practice. The exam wants that full definition. Writing knows the regs is not enough, you must link competency to applying the regs safely. Candidates often write only arcing is dangerous. The exam wants details. Hazards include arc-eye, burns, molten spray, and blast pressure. Causes include loose or damaged joints, faulty switching, or conductors clashing. You get the mark for naming both hazards and causes, not just saying it's dangerous. Many candidates know loose joints cause heating and stop there. The exam wants the detail. Over time, joints can loosen, oxidize, or fail under vibration. Proper connectors, correct torque, and strain relief are essential. The mark is for showing you know about long-term reliability, not just the immediate effect. Everyone knows copper, but the exam wants the link between conductor and environment. Aluminium needs special terminations, nichrome is only for heating, and stranded copper suits vibration. The trap is when two look acceptable. The mark is for choosing the best match to the installation conditions. Most can name TPS or TRS, but the exam asks for features and uses. TPS is fixed wiring, TRS is rubber sheath, MIMS is fire resistant, SWA is for underground neutral screen, reduces interference. Candidates lose marks when they confuse them or forget details like MIMS needing end sealing. Candidates know the list, but marks are lost when they don't match method to the scenario. For example, a portable appliance needs a plug, while a fixed heater may need a PCU or direct connection. The key detail is not just naming a method, but choosing the right one for the right situation. And that brings us to the end of this review. The important point is this: you already know the basics, but the exam doesn't only test that. It tests whether you know the specific detailed points that prove competence. Most marks are lost because candidates either overthink tricky wording or don't recall the finer details. If you master these 8 areas, you'll avoid losing marks on simple-looking questions and give yourself the best chance at a top score. Now let's do a quick review quiz. We'll focus on the 8 error areas, practice the tricky details, and see how well you can pick out the exact points the exam is testing.